it is being recorded.
Okay, thank you, sir.
Okay? Problem. You should see on your top left-hand side that I'm recording.
On my screen, sir, I don't see anything. I don't know about anyone else.
Can anyone else confirm that that I am indeed recording? You should hover your mouse over there. It will show that I'm recording.
You are recording, say.
Yeah. Okay. I'm going to go to the section that deals with piling in the standard system. You'll find that on page 20. When we look at what the standard system says, on page 20, before I get to that, we generally use piling in areas where the ground condition for the structure that has to be constructed is not suitable for ordinary construction type. It is generally found that when we have tests done of the soil, where the engineer would then advise that different types of foundations to be used, and they would, in all probability, especially where we have aggressive movements such as in the form of clay, or even where it's very sandy soil, that we would have piles that are being used in order to support the structure. And generally what the piles do, the piles would be that element that transfers the load into the ground, but that still allows for movement, be that mild or be that aggressive. I remember those of us who might or might not know the Doranginza Hospital. I was involved in the project in the Doranginza Hospital, the second phase. That was from 1988 until 1988 until 1993 was I involved on that project. And we encountered aggressive clay in that area. And the design there was that we would have piles, and some piles would go down to 15, 16 meters. And on top of each pile, we would have a pile cap, dependent obviously on the load that was transferred. And we also would have ground beams that would be casted by 150 millimeters above my ground level ground beams. And those ground beams, the load would then be spread through those ground beams and down into the piles, which made it possible for construction to take place there with minimal cracks, as all the loads would then be transferred down into the soil through the piles and evidently the pile caps on top. Now, if you look at the standard system on page 20, it says that the nature of the site within which, with regards to the contours, the water tables, high and low water levels, strata through which the piles would have to pass, shall be described. Now, I have another video that I show where it shows where the piles go through the different stratas of different types of soil conditions. Now, the nature of the work and any limitations on the methods to be used and special conditions such as piles that are sunk from a basement level and from any level other than ground level shall be so described. So we will not always get piles only from ground level. We might have a basement, and under the basement where we find that the soil conditions would not be conducive for an ordinary platform or foundation, where we then would have piles, and we describe those as piles below our basement level. Trowel piles, raking piles, and piles in contact with one another shall be given separately. So when we look at, very important, it would be clause number 3 on page 20 is the establishment of plant, etc. on the site. Now, as you saw in that animation that I pointed out there, you notice that the machinery that they use for piling appears to be very expensive. It is indeed very expensive to have piles cast and to have piles drilled and all of that. So it's important that we measure for the establishment of the site for each and every pile. It's important that we measure that we afford the contractor the opportunity to price in the establishment, because we cannot have one pile drilled this week and say, no, come back next week and come and do the second one, and come back the week thereafter and come and do the third one. We would have the establishment of the plant is very expensive. One of the companies in South Africa, Frankie Pile, that I've used a couple of times, they would come out, establish their site, they'd bring in their augers, and they'd come and drill, and they'd say, and you'd have to have the area ready for them, which is more cost effective if you could do that. So the establishment of plant for testing, because we also need to test the piles. It's important that we do that. And setting up of this plant at each pile position, for each and every one, you need to measure for that, because it's not just a question of taking a drill bit like you would use an ordinary drill bit and go and drill in there. It is the establishment, ensuring that the pile, that the angle of the pile is right, that the pile is perpendicular, that the depth that we need to go, that we know what the depth is that we need to go to, and the like. So it's important for the setting up that we know the setting up of our piles. One of the important aspects also would be that we need to ensure that we indicate how many piles need to be drilled and the different lengths that those would get to. Now, for the reinforcement of the piles, I mentioned earlier that we'd have our piles just on the straight, our vertical rebar, as you saw on the video, and we'd also then have our spiral rebar that goes all the way around the vertical, and that is where the formula that we use for the spiral that we had in first year, and also in first year that we would use that formula of the length equals the square root of c squared plus p squared, and all of that multiplied by h times the height, or multiplied by the number of p's that we would have. So that's just a formula for calculating the spiral. And we would have to, it shall be given in accordance with the principles laid down in concrete formwork and reinforcement, and our reinforcement is measured in tons. When we expose our piles for inspection, we need to expose the piles, and our description shall include for the excavation and the backfilling. Now, you would have seen there that we knock back, that we cut off the top of the piles to expose the rebar. Why was it needed? It was important for us because the pile would be joined into the next section, which would be the pile cap, and the pile cap then in turn would be connected either by the means of ground beams or through the columns, as you've shown in the as you were shown in the illustration. Cutting off our piles, we measured in number, cutting of sheet piling measured in meter, and stripping back the head of the concrete piles to expose the reinforcement, as I mentioned, would also be measured in number. Also need to test those piles, and we get told what it is that we need to work with. And we would generally now be looking at auger piles. What is an auger pile? If you know what an auger drill bit is, you know what an auger drill bit is? It is a drill bit that is almost helical in shape, and as it drills down, it removes the soil as it goes down. Right? So then, looking at auger piles, for the drilling is measured in meters, and it is very important that when we look at the measuring of the drilling, it shall be separated in groups not exceeding 10 meters deep, and thereafter in successive depths of 5 meters. So what does that mean? It means that if my pile depth is 16 meters, First and foremost, I would measure up to. What did I measure up to? I would measure, if it says it is measured in groups of not exceeding 10 meters deep, and thereafter in stages of successive depths of 5 meters. So it means that I'll measure up to 10 meters, and then I'll say exceeding 10, not exceeding 15. And if whatever the difference is there, then I'll say exceeding 15, not exceeding 20. That is how I would be measuring my pile depth, the drilling. At the bottom, it was not shown in this illustration here, but at the bottom of the pile, we generally would measure reaming of under-reaming for an enlarged foot. Now, I would just try and illustrate this. As you can see me, I'll try and illustrate this by using my hand. You see my hand, if this is the pile, if this is the bottom half of the pile, that you can see the bottom of the pile, this would be the pile shaft. But the under-reaming would do that. If I had to stick my hand in a hole now and I'd close it, I would not be able to remove that. So what the under-reaming means, the under-reaming says that when we measure for under-reaming, it actually does that at the bottom in order to create almost like a claw. Those of us that know a knob kiri, it has a knob at the bottom with a shaft going up. And this would then prevent that pile from being extracted or pulled out of because of the under-ream section at the bottom. I will draw this in a while just to illustrate exactly what it is that I mean. I could possibly try and draw this here, but I doubt whether I would be very successful in doing that. But I'll use it on my other device in a short while. And that shall be given, it measured in the number of times that we under-ream, and it shall be given extra over drilling. Right? Now, very important is that drilling is at risk of collapse and keeping excavation free from water would be deemed to be included in my description for my drilling. I'm not going to measure that separately, because how will I ensure that does not collapse? It will be measured within, and we will, dependent on the type of soil, we will then determine how the type of piling that would take place there. Work in material of a more difficult character shall be measured in meters cubed, and it shall suitably be classified as and given as extra over drilling and under-reaming. Right? The same way that we've done in our normal excavations, we would use this as extra over. We'd measure that extra over, and this would be, if it's in soft rock or in hard rock, it would be given, we'd be told where it would be in under-reaming or in drilling, and we'd measure that in meters cubed. Describe casing to prevent the collapse of the excavation or to exclude subterranean water. We measured in meter. If we have to do a casing, what is a casing? If we have to do a casing going down to prevent that, then that is what we'll do. The casing will then be removed once the concrete has been cast. The concrete in my pile will be measured in meters. And it will be measured through the enlarged feet. I will do a little drawing or a little sketch and illustrate that. Maybe I should do that whilst I am busy with that here now. Okay, I'll just take a step back and speak to you about the under-reaming. Now, that is my pile. The under-reaming refers to that section there. This here would be and that would be the oops. Now this would be the under-reaming that we see there. As you can see there, with that this foot is now enlarged. If that is my pile, that this foot is enlarged, and if we have a hole that this would not be able to pull that out, will not be able to pull that out. And when we measure the concrete, we measure the concrete as according to the standard system, measure the concrete through to the bottom there, and that concrete is measured in meter, and it is measured through the enlarged foot. Meaning that we would then come back at a later stage after we've measured that to come and measure all the concrete all the way around. The additional concrete in the enlarged foot is measured in number, and we'll indicate that in number. The formwork to the concrete above ground level is measured in meters. So that is just an idea of what it is that we would be looking at insofar the piling is concerned. Are there any questions at this point? Nothing. Okay. Then we would then take ourselves to our first drawing, which should be found on, which is RC 008. And when looking at RC 008, the first thing that I would look at is I'll notice that I now have a schedule here, or a table. What does the schedule tell me about my piles? It tells me how many I need, right? I need 14 of. It tells me what the diameter is. In this instance, it is 600 millimeter diameter, right? It also gives me, what is this? That also diameter. You know what that is? That means this refers to the diameter of the enlarged foot at the bottom there. Got it? That is the enlarged foot, which is 900, it says. Then I have L. L would be the length of my pile. You can see over there. We have the mild steel, which comes in my helical. We have that as 12 millimeter diameter. And oops, my apologies. I'm wrong with that. tells me L is my length. And it tells me what the diameter is for my vertical steel bars. That is for my vertical steel bars. My vertical steel bars. And it tells me how many we have. We have in this bar, we have 8 of them. Also gives me the length of that steel. And in the spiral steel, it tells me that we have 10 millimeter diameter, and it gives me that my P is 180 millimeters. My P is 180 millimeters over there. What also is very important is that it indicates that my space between my rebar on the side of my excavation is 60 millimeters. Right? And if that is 60 millimeters, it means that the diameter, the internal diameter would be 600 minus 2 by 60, 120, and that leaves me with diameter of 480 for my rebar. Can we all see that? Have I done? I've said this minus that and minus that one on that side, and all of that gives me 480. You can see that. We'll get to those calculations a little later. Okay? We now look through and have a look at the information that is given to me in my notes. Information given in my notes, it says that my concrete cast in situ piles is to be cast to a level of 99,400, which is my reduced ground level, as you can see there. That's where that tells me that we had already done bulk excavation down to reduced level, and that was at 99,400. It tells me that my concrete to be stripped back for the pile caps is that we have 30 MPa concrete. So the stripping back, that section would be stripped back. And with my pile cap being 600 deep, it is possible for me to determine what that section is that needs to be stripped back. I'm also given the size of the pile cap. The size of my pile cap is 1200 by 1200 by 600 deep. Okay? I have the top of my pile cap. My level is 99,600. And if my level is at 99,600, my level over here is 99,400, and my pile cap is 600 deep, I can now determine what that depth is there by saying that 99,600 minus 99,400, that leaves me with 200. So what does that mean? It means that I now need to indicate that I'll strip my pile cap back by 200 millimeters. The standard system says to me that stripping back my pile cap The heads of my pile cap to expose the reinforcement shall be measured in number. So I will then indicate by how much it will be stripped back, and that will be 14 number, which I got over there. Everybody clear with what remember, I've not measured anything. I'm just going through my drawing, just trying to understand my drawing, just trying to understand what the notes and what everything is telling me. Mr. Sekwakwa.
So, where did we get the 99,600?
The 99,600? You? See it there? Top of my pile cap. 99,600. I have that there. It's giving me a 600. It means if that is 600, it means this must be 99,000. Okay? Because that is 99,400, I take that off that, it leaves me over there with 200. With me, Mr. Sekwakwa? Right. I'm sorry, I did not show that in the drawing there. But in a nutshell, that is what it is that we are doing. What we are looking at here is trying to understand exactly what it is that we need to measure over here, and understanding the drawing. One other important aspect is the following. You now notice that I have a 60-degree angle at the bottom of my enlarged foot. And why is that of significance? Why is that of significance? We will find out later on when we need to determine the concrete that we have to cast in our section. So when I now go through and I need to start measuring this, I would now have a fair idea of what all it is that we need to measure. So, in getting to this, starting out, we would indicate in my description that we would then indicate in my description, first and foremost, I would say the following in 14 number augured cast in situ reinforced concrete piles. I indicate that there are 14, and I indicate that purely because of what I had detected from my notes, purely through what I had detected and was given, telling me how many it is that I need to do. Okay? So that is where we start out. Start out with the following, and this is underlined. This is a subheading, because I'm telling the contractor exactly how many piles it is that you need to price for. And we allow for the establishment of plant, etc., on site for piling operations, and the removal thereof on completion. Remember I said that we measure that, and when we look at that, it's important that we allow for that, and that is measured as an item, and we also allow for the subsequent establishment of plant on site for the testing of piles and the removal thereof at completion. So, what are we saying? We are telling the contractor that they need to allow for bringing the machinery on site, placing it in position, removing it from site, placing it in position for every pile that is there. Then also for the testing thereof. And we'll be told how many tests we have to do. If you have a look on this on the notes here, it tells me that we need to allow for the testing of any 3 piles. So we get told how many piles we need to test. Why do they do that? They do that so that we do not have to test each and every pile, because we would pick up on a pattern. If the test results are all within, of those that have been selected are all within a range, the same range, a margin, then the engineer would know that this contractor did not take shortcuts. But if we find that the discrepancies are huge, they would then investigate and request the contractor to test more of these piles and bring the results. Right. So now we also need to allow for the setting up of the machinery at each and every pile. And that, in accordance with the standard system, is measured in number. There's 14 of them. We allow for the setting up of plant at each pile position. Okay. We said earlier that this there is 600 millimeters diameter. And I now need to allow or instruct the contractor to price for or the augering into this ground. So we will say auger in earth for 600 millimeter diameter, pile not exceeding 10 meters deep. And why do I say that? Because that is what the standard system tells me, and I will now be measuring to that depth of 7 meter 800. So it will be 7 meter 800. The standard system tells me that the measuring of the piles, augering piles, is measured in meters. So I'll write the 7.8 meters in my dimension column, and I would have 14 of those to be measured. Also need to allow for the bottom for extra over for the augering and under-reaming, extra over augering for 600 millimeter diameter pile, for under-reaming to an enlarged foot of 900 diameter. I know that that is 900, that was 600. So this would then be measured in number. Our description would read, extra over augering for 600 millimeter diameter pile, for under-reaming for the enlarged foot, the 900 millimeter diameter. Now I indicate what that diameter at the bottom is. I indicate that the 600 millimeter pile would be under-reamed and enlarged to a 900 millimeter diameter footing. We also have to cast away that material that was cast in there, that we drilled in there. If I take that length there, 7 meter 800. And as we drill down, remember that we drilled all the way down to there. So that's 7 meter 800. We then ensured that the contractor had priced for doing the under-reaming. But now all of this that goes in here now needs to be carted away. So what do I do? How do I measure this? I now use, and I know that that is 600 diameter, meaning that I would have a 300 radius. So I would now measure extra over augering and under-reaming for carting away the surplus excavated material. And in this, I would have to take out, cart away all of that soil that is shaded there in the color red. I'd have to allow for the carting away of all of that. What do I do? How do I measure this? I measure this by starting out by measuring that through first. I would then have 0.30, 0.30, and 7.8, and that multiplied by pi and by my number 14. Where do I get the 0.30? That is my radius. That my formula is pi r squared h. So I have my radius, my height, and pi, and the number that I am needing. So I've now measured all of that. That is colored in over there. That is all of that there. And I need to measure this section here. Need to measure that. And how do I measure that? How do I measure that? I know that with this being 900 in total, that being 600, that will be 150, and that will be 150. Okay? I also have another known aspect, and that is that my angle there is at 60 degrees. It's given to me. And I need to determine that. And how do I determine that? You guys have all done centroids, and when you've done cross-sectional properties, it tells me that if I need to now determine the center point of a triangle, what do I use? What do I use? I first and foremost need to determine what that height is, and I call that y. To determine what that height is. Can I do that? Can I calculate by y? I've got someone saying, yes, agree, I can calculate it. What would that be? I would now use, what would I use? I need to use, I can say that the tan of 60 is equal to y over 150. Is that correct? Show me a thumbs up if you agree, or alright, I've got some people that agree with me. Okay. So that means that y is equal to, what does that mean? That means that y is equal to 150, 10, is 150, 10, 60. $150, 10, 60. And if I have a look at that, and if I go in and I say that 150, 10, 60 gives me 260 millimeters. Do you agree with that? So it tells me that y is equal to 260 millimeters. Right? So I can now, based on what I've just calculated, I can now determine what the center point for that triangular section is. Do you agree? And now I don't see any thumbs up now. I need that 260 to calculate what the center point of that triangular shape would be. Would the center point there be 260 divided by 2? My question is, would my center point, if I can just draw that through there, would that be 260 divided by 2? Would that be the center point for that triangle? Well, I've got some people say yes. I've got some people say, I say no. Why not? What does cross-sectional property says? If you can remember back to your third year structures and concrete, in the structure section when you did cross-sectional properties, what did we say? How did we determine the center point or the center point of gravity or the cross-sectional point for that triangle? What do we do? We said that we go a third from the perpendicular base. Can you remember that? A third of my base. And what is that third? It will therefore be my base that is there, my perpendicular base that is there would therefore mean 260. What is that? Multiply a third. So my center point would therefore be, what would my center point be? Talk to me.
87, sir.
Will it be 87? Okay, Jan says 87 millimeters. Right, let's see. Okay, but what do I need? Is that what I need? I need to determine, remember I need to determine what the volume is. Let's just use different color here, and I'll just shade it in for now, not color it in. I need to determine the volume of that all the way around. How do I do that? How do I do that? How do I do that? For now, I'm not gonna be using that. But I'll keep that there. I'll keep that there. What do I need? Remember now, I need to determine what? I need to determine how I get this dark blue shaded section measured in there. And what I would how I'd go about doing that is determining, know that there is 300. Agree? That across there, that's my radius, right? And I said I need to work with a third from the perpendicular base. If I need to determine that there is 150, A third of 150 is 50. Happy with that? So it tells me that my radius for my enlarged foot is 300 plus 50. That is my center point. Okay? But now what do I need? What do I need? I now need to determine what the circumference is on that 350 if I would be using the formula saying my circumference equals 2 pi r, what would that be? That would be 2 times pi times 0.35. Okay? With me? So that then gives me, if you calculate all of that, what do you get? You get 2.2. So that equals 2.2. That's in meters. Okay? So I now know that my circumference for that enlarged foot is 2.2 meters. Now to determine what that volume is there, I would now go in where I've had, and I'd add here, it would be 2.2 multiplied by my extended section of 0.15 that we have there, multiplied by my height of 0.26, and that would be multiplied by half because it is a triangle, and it will be multiplied by 14 that I'm needing. You with me? You with me? Great. This is a smart class. I don't have to struggle with this. This is a smart class. Okay. Now, of course, there's another way in which we could have done this. Shall I show you the alternate way in which to do this? Because this here can be a little confusing. Shall I show you the alternate way in which you can use that? I'll show you the alternate way, the way that I would actually prefer. If we go in and we have a look at this, just gonna, remember this is on the recording, I'll just clear this here and draw this out again. I'll need that, I will not need that. And what I would do, yes, I would not need that. But I'll need that. So if I draw my line there, I've determined that y equals 260, so that there is 260, meaning that the remainder there would be 800 minus deduct 260, and that would give me 7.54. Okay? So that is 7.540. All in agreement that if I add that plus that, I get 7,800. right? So what I do now I say 0.3, 0.3, 7.54 times 5 times 14. What have I done now? I have now measured that. Measured that. I've not gone into the foot. Now I ask you, what shape do I have here now? What shape is that? That's the shape that I have now. I now have a partial what? I have a partial pyramid, isn't it? And what I then do, this is the formula where if I cut through that, this is the shape that I have. And I can see there. But I'm not going to be looking at that now. If I cut through that, what I would be using here now, I now, instead of using the other formula that can create confusion, I prefer to use this one, the one that says h over 6 equals a plus 4m. Do you guys know that formula? You know that formula? Right. So I say that I would much rather use that formula to determine the volume of that. You might not agree with me, you might agree, you might not agree with me. Okay? So that's what I say. So I now say that instead of going through all that other calculations and formulas where I can confuse myself, I would rather use this one, and I would say that I'm just going to clear, let's say you guys know that it's 260, we've calculated that. Just clear that, and I would say 0.45, 0.45, 0.26 times 5 times 1 over 6. That is 8. With me? Then I say 0.3, 0.3, 0.26 times 5 times 1 over 6. All with me? Right? Now I need to determine. And here I say 300 plus 450, that equals 750 divided by 2, that gives me 375. Then I say here, my next one would be, because M is over there, 0.38, 0.38, 0.26 times 5 times 4 over 6. And if I've done that, I can then, let me then say that I have also measured. Agree, or are there questions with what I've just done? Agree with me? Now, which one is easier, number 1 or number 2? Welcome to type in the chat. Welcome to say, to shout it out and say which one you prefer to use. Number 1 or number 2? because someone wanted to say something, but then disappeared again. Ms. Zokobe, you wanted to say something. Which one do you prefer, number 1 or number 2?
Number
Says
1,
number
sir.
2. Mr. Sizima?
Number 1 for me, sir.
Who said number 1? Ms. Zokobe. Mr. Kwakwa, you say? But I'm just showing you.
Number 2 has always been nicer to use.
See, I'm just, all I'm doing is, if you can recall, if you can remember, if you were in my class in first year, then we had this shape, it was just upside down. Mr. Sisiba?
Sir, where did you get that 450 for A?
900 diameter for my radius. 900 divided by 2 equals 450 for my radius. With me? Right. So all I've done here, and to me this is an easier formula to remember than the other one, because other one can create confusion. Not that it would be wrong if you do that. I would go with either way. But I just feel that a lot of times we overcomplicate things, and I love keeping things simple. And I've just broken this down a little differently to how others have done. Right. So we are now determined what it is that we have to the volume of the soil that will have to be carted away, and we would use these formulas. Then I have to now measure the concrete, and the concrete standard system tells me that in measuring the concrete in my piles, it is measured in meters. Say that my concrete is measured in meters, and it is measured through the enlarged foot. I'm just going to leave it as it is there, and when I do measure the concrete, I will now measure this. If I had to measure this and that in volume, I would have gone ahead and I would have measured in the same way that I had measured the previous one. But because I will now be measuring the concrete from the top all the way through my under-reaming, I will measure that in meters, and I know that that is 7 meters, 800, and it'll be 30 MPa reinforced concrete in 600 millimeter diameter piles, and it is measured 7.8 meters, and I have 14 of them. And the additional concrete that goes in there is now measured in number. Measured in number, and all we are doing is that the contractor will therefore have to determine what the volume is of that concrete that has to go in there. So we say additional concrete 30 MPa in the enlarged foot, 900 millimeter diameter for the 600 millimeter diameter pile. So we indicate and we tell the contractor that the enlarged foot, so we give all the information to him in order for him to be able to calculate what that volume of concrete is. So we just tell him how many it is. We tell him that the enlarged foot is 900 millimeter diameter, and that the pile is at a 600 millimeter diameter, and there's 14 of them. Right. See a screen. I remember now back in my day when I first dealt with computers, we had a command. We didn't work in Windows. We worked in what's it called? We didn't work in Windows back then. It was in can't remember now. But we used CLS was clear screen. When you punch CLS, your screen was cleared and there was nothing. If you didn't save, you lost all of it. There was no auto save as Windows have. So we now need to strip back the head of my pile, and we determined that we need to strip this back by 200 meters for that section there. To expose the steel so that it can be joined to the structure above. We say strip back the head of the 600 millimeter pile, diameter for a length of 400 millimeters to expose the reinforced concrete. Okay, yeah, this one, but I do not see that it could be 400. In actual fact, sorry, it is 400. My apologies, it is 400. It needs to be stripped back by 400 because the difference there between 600 minus 400 is, so we need to strip it back. So what I said earlier on was wrong. I apologize. Sometimes even the great make mistakes. So we need to ensure that we strip it back 400 millimeters. I thought that was a joke. Huh? But anyway, we strip it back by 400 so that we can expose the top of the pile cap. Expose the top of the pile cap so that we can join that to the new to the structure that will go over it into the pile cap and wherever it will be joined to. So we've stripped back the head of our 600 millimeter pile for a length of 400 millimeter to expose the reinforcement. And what that does, if you have a look at that pile cap that you see, if this is my pile cap, that's my pile cap that needs to go in there. And I have had my pile in there. We would strip this back. We strip all of that back so that the steel therefore be exposed that would be exposed and that steel over there could be joined in with the new cage. So that would be the pile, and that section that is the purple would be exposed, and my pile, that goes down there. Only the steel would be exposed, that will be joined into my pile cap and the line. So we've stripped back .400 millimeters, and we measure that in number. There's 14 piles you see. So we say allow for the testing of the 600 millimeter piles to a maximum of 2,000 kilonewton. Now the engineer will decide based on the load that would be imposed on these piles, the engineer would determine as to what the maximum load is, what the maximum testing strength would be. And in this instance, they said needed to be a maximum of 2,000 kilonewton. And we only doing 3 of them, because over there we were tasked to test 3 of them. Also, the 3 would be advised by the engineer. The engineer would come in and say, I want you to test this one, I want you to test that one and that one. They would mark them. The contractor would not know beforehand, so that they can ensure that that one meets the necessary requirements and then JIPO on the remainder. I then also now need to come back and need to measure my reinforced steel. Now measure my reinforced steel. Told that it's 7 meters 800. The diameter is 12 millimeter diameter. And I want to go back to my standard system that tells me about the length, measuring the length of steel. Reinforced steel. Now go to my standard system. Right. The reinforcement, it says that reinforcement shall be measured first and foremost in tons. Okay? Then different diameters shall be given separately. Also says that the steel will be measured in lengths exceeding 13 and not exceeding 18 meters. Thereafter in stages of 1 meter. So when I go in, it means that my respective categories for my steel would be not exceeding 13 meters, exceeding 13, not exceeding 18 meters, and thereafter it would be exceeding 18, not exceeding 19 meters, and thereafter in stages of 1 meter. You with me with how we measure the steel reinforcement? So when I look at my drawing and I see that my length as given to me in my table tells me it is 7 meter 800, and it means therefore that it relates to not exceeding 13 meters. So when I measure my steel, I will then go in and I would say I'll then go in and I'll say that I have my 12 millimeter diameter mild steel reinforcement in piles not exceeding 13 meters long. And in my description, I will then say, because the standard system tells me that it is measured in tons, I will then say times whatever the weight is per meter in order to arrive at my overall weight for the steel that goes into that into that 600 millimeter pile. So it was given that my length is 7.8 meters. 7.8 meters, and I was told that there are 8 per pile, so it will be times 8, and I have 14 piles. Whatever this total here is would then be multiplied by whatever the weight per meter is, and that we would then measure in kg or in time. All clear? And what I measured there, all I measured here, that's 7.8 meters, would be, if you could visualize this, would be 1, 2, 3, 5, 6, 8. Would be those rods, and if I looked at it from the top, 1, 2, 3, 4, 5, 6, 7, 8. That is what we've measured there. Right? All with me. Right. But now I look at this, and I also notice that it said that I have 10 millimeter diameter rebar, mild steel. That my spacings are 180, that is 180 there, my P is 180, and I need to determine what the length of that spiral reinforcement is there. So I indicate and I say it is 10 millimeter diameter, mild steel spiral or helical reinforcement in my piles. Again, I will be multiplying and I will have to determine what the weight of that 8 millimeter mild steel spiral reinforcement would be. So my formula says to me that L, which is the overall length, is equal to the square root of C squared plus P squared multiplied by the number of P's. Okay? The number of P's. So, what is C? Where do I see C? I say that C is equal to pi d. You agree with me? C is equal to pi d. My circumference. But now, I have a look at where my reinforcement starts and ends. Remember earlier I said that we would be looking at that 60 mils there. So now I would say my 600, which is my diameter, minus 2 times 60, which is 120. So C therefore would then be my diameter would then be therefore be 480 millimeters. So 480 millimeters. If I need to do that formula, I I need to do that formula over there. It's important that I now state that for my C, I will therefore then say remember that's 480? But 480, I will therefore say that I have pi times 0.48 and that squared plus 0.18 squared square root of that multiply by my number of p's, so it means it will be 7.80 divide 0.18. Are you guys with me? Can you guys see what I've done here? Everybody clear on what I've done? Right? All clear what I've done. So, now, what am I doing? When I square all of that out, I then get 65.86. 65.86 meters. So each one of these be equal to 65.86 meters, and I have 14 of them for my reinforced, for my 10 millimeter diameter mild steel reinforcement. Okay, but let's just have a 5-minute break, a leg stretch, and we'll come back and we'll start measuring the power caps. Okay, I'll be back now. Just need a little leg stretch, and then we can look at the power caps. Right? But I also just need to make sure that what you are telling me is in fact correct, you know.
Okay.
Well, I cannot just believe what the student tells me. What do you mean? Over the years, we've learned not to trust students.
Yeah, please just confirm.
So just confirm. Can someone else check for me? And please confirm for me. What was that? I did not get that.
That's what I also called.
You also got that. So you got 65.81. That's correct. So you're saying that the 10 millimeter spiral reinforcement gives you 65.81 meters. That's what you're saying? Right, okay, great. No, that's cool. See, I use 22/7. I'm old school. I used to calculate the value of pi. We didn't have calculators so we use 22/7 and then you come out. So that is fine. I can live with that. I'm cool bananas with that. Thank you for pointing that out to me. So at least I know now that I need to go back and check and change that to saying pi and not 22/7. Okay, right. And I'll say that we will look at the power cap. And with this power cap, in this instance, it is straightforward. A power cap, I can draw this. Right? That is what the power cap would look like on plan. In plan and on the section, this is what that would look like with your 1200 by 1200 as is indicated on the drawing there. So when we measure our power cap, we have a look at this and we notice that is my reduced ground level. Okay? So I've already excavated in open face to that level. Whatever happens now, whatever I start looking at now would happen my reduced ground level. Okay? So I now need to excavate in pickable material or in earth or in whatever the soil conditions are For pile caps, below reduced level, not exceeding 2 meters deep below reduced level. So my description come out and would say the following. Excavate. In earth. It's important when we say what we're excavating for. For pile caps, not exceeding 2 meters deep below reduced level. Right? And if I look at that, whatever that soil is, that would be carted away. The description would be extra over all excavations for carting away surplus excavated material. And my size here is determined that that is 400 there, so it is 1200 at 1200 by 0.4 and I have 14 of them. But I also need to take into account that my excavation that I would have already excavated, that. So I therefore need to deduct, that would be 0.3, 0.3, 0.4 times 5 times 14. All with me. That red there, that's red section there. Okay? That is for, as I said, that is for the pile. Because that pile, I've already drilled that hole down there. I already cast the concrete in there. And I've deducted, I've cut it back. So I've already done that. I will not be over measuring that by measuring that excavation already. Because remember we said that when we measure in quantity surveying, we measure net. Sequaqua?
Sir.
Go ahead.
Why did we need to measure the whole 7.8 meters of the whole pile cap, the whole pile? Couldn't we just from the 7.8 deduct the 400 and then measure it up to there, and then from then on, knowing that we have the reinforcements that are going to go through until 7.8, and then continue with that way, and then when we come to the pile cap, we don't need to do these remeasurings and deductions of the pile cap, the pile initially.
You can do that, but remember, we are human and we tend to forget certain things. All that we've done here is that we've measured. But remember, you can also sometimes have different piles that are different heights. But you're more than welcome to do that, provided that if we now square everything at the end, that we'd arrive at the same quantities. Same volumes, the same linear meters, the same square meterage. Are you with me? But But remember, the other big thing is that when we measure, and this is how piles are done, we measure the concrete through, and then we strip it back to create, because there is a bond on those on that steel, and where the remainder of the structure now gets joined on that top there. It's important that that rough edge is created so that we can have that work. But if you want to measure it that way, you're welcome to do so. As I said, I will then do a calculation at the end to determine whether your volumes are the same as mine and your lengths are the same as mine and all that. Go ahead, Mr. Sikwapa.
So in such a case, I've noticed that with this method, we have deductions and additions and all that. And I'd like to believe that when you're marking it, those are probably 1 marks or 2 marks or whatever. Now, let's say I used it the way that I thought it was probably easier for me to perceive. What about those little 1 marks that I won't be adding? When it comes to the total, are you going to grant me those marks? Or since I did not put in that step, I'm not going to get those marks?
No, I will afford you those marks. I would grant you those marks.
Oh, okay, thank you.
Anyone else want to ask something? Okay, so we say we're keeping our excavation free from water, and then for this base, not base, my apologies, for this pile cap, we now need to do risk of collapse. Now we have to measure the risk of collapse here. And the risk of collapse that we measure here would be there. Now look at this. The risk of collapse there, and it would be 400 millimeter deep. Another thing I'd like to say, Mr. Sikwapa, why I also use to do things the way I've been doing it, is that because these lengths and some of these dimensions are carried through. So you do not have to do an additional calculation in order to arrive at certain lengths. Also, one is generally pushed for time, and if you're going to have to spend the time in deducting those and in order to arrive at the net height and so on, you might spend a lot of time on that and find that at the end you were not afforded the opportunity to complete. So it's just that's one of the reasons why we also do that. We work through and deduct off. It's just easier. So when I look at, and I see there's my 400, I want to measure my risk of collapse to the size of my pile caps, not exceeding 1.5 meters deep. And my dimension would be my risk of collapse. Okay. All happy with how I arrived at my dimension of 4.8. Was it E? That times 2, 3, 4 gives me 4.8. Okay. Now do my reinforced concrete now in my power cap. So reinforced concrete 30 MPa, 19 millimeters stone in power caps cast against excavated faces, and that would be 1.2 by 1.2 by 0.6. My volume there. But I also note that I have above the ground, I have formwork that needs to go in there. And that height there is 200 millimeter. The standard system tells me that when I do measure formwork not exceeding 300 millimeters high or wide, that I need to measure that in meters. So I'm saying here smooth formwork to the sides of my power cap projecting above the ground level not exceeding 300 millimeters high. Why smooth? I mentioned earlier that in most instances, when we have piles, the power caps that would protrude would be the final finish. And so in this instance, we would have smooth formwork so that the finish would be smooth. When I look at my smooth formwork, it says that will therefore be or 1.2 by 4 by 14, or be 4.8 by 14. Now I have a slight question here. What happens if my formwork is required to be over there? If my formwork is required to be at the where I've indicated in yellow, my dimensions would therefore then be smooth formwork to size of pile caps, and that would then be measured in meters squared, and it would be 1.2 by 0.6 times 14. But when we are tasked to do that, we also now need to ensure that we measure for working space. We do then say excavate in earth for working space to provide space for the formwork to the size of the pile caps not exceeding 500 millimeters deep, flush with the excavated surfaces. That would then measure whatever the length was of 1.2 by 0.4, because that is what we have below the ground, and that will be times 4 times 14. Only if we are told that we need to ensure that there's formwork for the entire pile cap. Right? We need to expose the 600 millimeter pile for inspection, including the excavation 6 meters deep into the earth and backfilling. Sometimes we are tasked to do that, and so we will state that, and we will measure. That will be 5 number that we do, and we also have to ensure that we do concrete test cubes, making and testing concrete test cubes, and we just allow for 10 of those. Reason being, so that they can determine that the concrete strength throughout for the entire structure had requested. And that brings us, ladies and gentlemen, to the end of this first piling question. Drawing. Now I would afford you guys the opportunity to ask me questions based on what it is that we have done this morning. Are you guys happy? Piling is easy. Walk in the park. No sweat, no stress. Where are my questions? Come now. Not have questions. Did I explain it well enough for you not to have any questions for me?
Hey, sir, I don't know if we're sure that we understand, but maybe it would be best if you asked us questions and then maybe we'll answer them.
But I ask the questions, Mrs. Ekwakwa. You reckon it's best if I ask the questions? Huh?
Yeah, yes. I mean, we've been quiet, eh?
Yeah, you've been quiet. You've not been responsive. Other times you're responsive. But the big thing is, guys, especially with piling, do you understand the reason for us having piles? You know, it's questions that we ask ourselves. Do you understand the reason for us having piles? Not the piles that we get in our behinds, no. Do we understand the reason for us getting piles? Do we understand the importance of ensuring that it is measured correctly? Do we understand the importance of finding all the information that is required? You know, it's just I look at questions, I look at sections such as that, and I ask myself, do I know exactly what is required of me?
So I have a question, actually.
Yes, Mr. Sekwakwa.
So what are the common mistakes that students make when it comes to piling?
Well, the common mistakes that students would make would be that they, like this drawing that I'm just putting up here, and I'm trying to, drawing is not. One of the common mistakes would be the fact that, I think I should just go back and put that other one up. That students would forget about deducting, that they would rather, instead of taking the 7, 8 to the bottom of the under-reamed foot, that they sometimes measure it to the top of the under-reamed foot, that they measure that to there, and that they would not include that in there. You know, some of the common mistakes would be that students don't deduct the space between your reinforcement and your excavated face, that they would calculate the length of the spiral, that they would, instead of using, sometimes you have 0.1, but you have 0.01 something, and that they would use that as 0.1 and not 0.01. But generally, piling is not, it is where you should make up, where you should not make mistakes. The one thing, however, that I need to say is that when I do work with this, that I generally try and create an interesting scenario where I have different sizes of piles and so on. It's important that we keep the different sizes of piles separated from one another. But generally, students do well when measuring piles. It's just things such as levels where students do not calculate those heights and that. Those are common mistakes. Okay. Next one. I want to show to us your. Now look at. I needed to actually turn this drawing sideways. No, not done there. Why I have not done that? No. Yes, this is just to do spiral calculation. This is taken from from my first year notes that I've included, where you can see the spiral and how you can calculate that. It is there for you to use. I need to turn this drawing so that we could have a better understanding of it. Because this drawing shows us you just added something different here, added 100 millimeter blinding, given the different levels and being told how far we had to strip them back. And we have different piles. One has 3 piles in the pile cap, the other one has 2 piles in the pile cap. Just adding a bit more. I'll be doing this drawing, excuse me, be doing this drawing with us as well. If you have a look at this, you'll see that there are 3 piles in the one and 2 piles in the other pile cap. And we are told type B that we need 4 of these, type B, type A, 4 of these, type B, 2 of them. So what we will do, we will now split whether it is the different types that we have, we will split them and not bunch all of them together when we do measure them. So I've not copied this drawing in properly so that I can actually work with it and be able to explain it a lot better. I can understand it, but it is. Maybe I should just upload that. Then I can talk about the drawing.